Good morning all, my name is Santhosh Kumar, Institute of Aeronautical Engineering. My topic is some basic gray level transformations. So, what are the gray levels? Before going to this, what are the gray levels and how we are transforming? So, first one, some basic gray level in transformations. So, in the basic gray level transformations, so what are the gray levels are there? Then how can we transform into that one? So, before going to the gray levels, we are going for the image enhancement. So, what is image enhancement? Enhancement is an image provided better contrast and a more detailed image as compared to non-enhanced image. Image enhancement has very applications. It is used to enhance medical images, image capturing in remote sensing, image from satellite, etc. So, the transformation function has been given below. S equal to capital T of R. So, what is the enhancement? So, it provides better contrast and a more detailed image as compared to non-enhanced image. So, this image has low contrast. So, I have to increase the contrast. So, how? What is the process? That is a image enhancement. So, it provides better contrast. So, contrast means it is adjustment of black or white color, and it is a detailed image to a non-enhanced image. Okay. So, before enhancement, what is the original image means? That is a non-enhanced. So, that image enhancement is the applications in this, and it is used for. So, what are the image enhancements are there, and what are the applications, and where we are using this one? So, the image enhancement are using in medical images, image captured in remote sensing, images from satellite, etc. So, that transformation function has been given. So, output is equal to capital T function and R equal to input function. So, output is equal to, that is a enhancement. So, the enhancement is equal to, what is the function I'm using? Enhancement technique, image enhancement technique, and in output equal to S. So, enhanced image. Okay. And capital D equal to image enhancement technique I'm applying. That is a capital T. And R is the input of the image. That is a non-enhanced image. And here, R is the pixel of the input image, and S is the pixels of the output image, and capital is the transformation function. So, what is the transformation function means? Enhancement function. Enhancement function here I am using. And the value of R, each value of S, image enhancement can be done through gray level transformations, which are discussed below. So, what are the gray level transformations? There are three basic gray level transformations: linear, logarithmic, power law. So, these are the three types. So, three types of basic gray level transformations: linear, logarithmic, and power law. So, we will discuss. So, what is the linear transformation? It is a one type of gray level transformation. So, first we look at the linear transformation. So, first we are going for the, what is a linear transformation? So, linear transformation includes simple identity and negative transformation. Simple identity and negative transformation. And identity transformation has been discussed. So, we have transformation has been given. So, the identity transformation is a straight line. Suppose I am taking identity transformation, that is a straight line. And in this transition, each value of the input image is directly mapped to each other of the output image, and the results in the same input image and output image, and hence it is called identity transformation. So, in this identity transformation, in the graphical view, it is a straight line, and this input image directly mapped to the each other of the output image. The results in the same input image and output image. So it is called identity image. So both input and outputs are same are there. It is like this. Suppose here I am taking 0 to 255. That is the x-axis, and the y-axis also I am taking 0 to 255. It is a straight line. So the input image and the output image are identity transformations. Same levels are there. Next one, negative transformation. The second linear transformation is a negative transformation, which is invert of identity transformation. So it is also called invert identity transformation. In negative transformation, each value of the input image is subtracted from L-1 and mapped onto the output image. The result is, so it is the input image. So it is a negative. In the camera's reels are there, in the camera reels are there. So that is a negative. So the image, the input image is converting the digital image. I am converting to the negative. So digital image converting to the negative. Is it possible? Yes, it is possible to convert to the negative. So in this case, what is the equation? S equal to L-1 minus R. So here the input image is a, here the picture name is a Einstein in 8 bpp bits per pixel image. So the number of levels in that is a 256, means 0 to 255 levels. So 255 6. So S equal to, so S equal to 255 minus R. What is the equation means? S equal to, so it is the equation for negative transformation. So in this negative transformation, S equal to L-1 minus R. So what is the L here? L equal to, how many are there? 256 pixels are there. The levels are 256. So L equal to 256 minus 1 minus R. So how much? 256 minus 1? 255 minus R. 255 minus R, and each value is subtracted by 255 and the result image has been shown. So what happens in that lighter picture of the became dark and the darker picture becomes lighter and it results image negative. So inversely proportional. So wherever the whitish is there, it is converting to the black. Wherever the blacks are there, it is converting to the white. So here what is happening means negative means inverse. It is going as an inverse transform, inverting of the identity transformation. Suppose here the color is white, but here what is the color here? The color is a black. Here what are the colors are there? The skin is all are white, but here some blackish is there. Some black. Here some blacks are there. So these blacks are here converting to the white. So what is happening means when we are applying the equation, what is applying means here the input image is a 8-bit pixel. The number of levels are 256. So we are applying this 256 in this equation. S equal to 255 minus R. So each value is subtracted by 256 and the result is that the lighter pixel become darker. Darker picture becomes lighter. So that is a negative image. So the equation is like this. Inversely proportional and dropping. So here 0 to 255, 0 to 255, it is dropping the values. So S equal to L-1 minus R, it is a equation. Suppose I am taking some examples here. So what is the output? Output equal to L-1. Suppose here, what is the here L equal to L-1? Here here L equal to suppose here I am applying what is the R value. Suppose L minus 1. What is the L minus 1 value here? 255 minus what is the R value here? R equal to 0. What is the answer? 255. 255. Next, S equal to L minus 1. What is L minus 1? L minus 1 is always a constant. Okay. 255 minus, I am taking this value now. Capital R equal to this value. Okay. 255 minus 255. What is the answer? 0. So here 127 I am taking 256 or 255 minus 127. So what is it? 128. So here also 255 minus 10, 245. 250 minus 10, 250. 255 minus 10, 5. Next, here 50 is there. So, what is L minus 1 value? 255 minus 50, 205. Here, 200 value is there. What is the value here? 255 minus 200, 55. Next, 100 is there. 255 minus 100. So, what is the value here? 155. So, here I am getting 155. Here, 50 is there. So, 255 minus 50, 205. So, these are the values. So, the input values are original image intensity values are 0, 255, 127 like this. These intensity values I am applying in this equation. I am getting the output values like this. Okay. So, logarithmic transformations. So, the logarithmic transformation further contains two types of transformation: log transformation and inverse log transformation. So, what is a log transformation? So, log transformation can be defined by the formula S equal to C into log of R plus 1. The inverse log transformation is the opposite to this function. Okay. So, logarithmic means here two types, logarithmic and inverse logarithmic. So, what is the need of the logarithmic? If I am applying the logarithmic to the original image, what is happening? We will discuss. Logarithmic transformation contains two types. That is a log transformation, inverse log transformation. The log transformation can be defined as a S equal to C into log of R plus 1. The inverse log transformation is opposite to the log transformation. So, here what is the formula means? S equal to C log of R plus 1. So, we will discuss. It is the output. Already we know that what is the C value, log of R plus 1, we will discuss. Okay. So, where S and R the pixel values and output of the image is C is a constant, and the value 1 is added to each of the pixel value of the input image because of there is a pixel intensity of 0. So, log of 0 is equal to the 1. So, 1 is added to make the minimum value at least 1. So, suppose I am taking R equal to 0. Example, R equal to 0 means 0 plus 1. So, C log of 0 plus 1. C log of 1. So, log 1 equal to 0. Okay. So, we have to add at least 1 to make the minimum value. Suppose here I am taking 0 means the value is 0. So, that is the reason if I have take at least 1. So, if I am taking 0, what is happening? 0 plus 1, 1. So, log 1 equal to 0. So, I am getting 0 value. So, if I didn't get any 0 value, so we have to take minimum or equal to 1. Minimum value I am starting from or equal to 1. And during the log transformation, the dark pixels in an image expanded as compared to the higher pixel value. The higher pixel values are kind of compressed in log transformation. The result is following by the image enhancement. So, all are under image enhancement techniques only. But the log transformation, the dark pixels of an image expanded as compared to the higher pixel values. The higher pixel values are kind of compressed in log transformation. This result is showing in the following. So, S equal to C into log of R plus 1. It is the original image intensity values. These are the logarithmic image values. So, here S equal to C into log of 0 plus 1. I am applying 0 plus 1. So C log of 1. Oh, what is the log 1 value? 0. So C into 0. What is happening? 0. So next I am taking C log of R plus 1. C log of, what is R value here? 255 plus 1. So 256. So C equal to, I am taking C equal to 1. 1 into log of, what is a 256 value? So then I am getting 2.4. Next C into C I am taking C equal to 1 log of R plus 1 means, suppose I am taking 127 plus 1. So what is happening? Log of 128. So 2.1. So log of this one. So C into log of R plus 1, 10 plus 1, 250 plus 1, 50 plus 1. That means 51, 200 and 100 like this. So what is happening? So when I am applying the logarithmic technique, the output values are like this. So these are the logarithmic images. These are the input original digital images. So the values of C in the log transformation adjust the kind of enhancement are looking for. It is the input image, that is a digital image. So after the log transformation, I am getting like this. Okay, it is the inverse of this image. So next one is a power law transformation. There are further two transformations are there. First one, power law transformation, that include the nth power and the nth root transformation. These transformations can be given by the expression S equal to CR with gamma. This symbol gamma is called, due to which this transformation is also known as a gamma transformation. So how we are applying S equal to C into R into gamma value. Okay, like this. Previously we discussed. Here I am applied C equal to log of R plus 1. In the place of C I am taking here gamma. C R with gamma is a constant value. So what is the transformation? Gray level transformation. Okay, so what is a transformation? We have to discuss. So the better image processing. What is the need of transformation means? We are going for the better image processing. It is take into account long range correlations in space, conceptual insights in spatial frequency information. What it means to be smooth, moderate change, fast change, and fast computation, convolution versus multiplication. So here every image we have to do the transformation. So why we are going for the transformation means we are getting the better image processing, and it is into the account of long range correlations and conceptual insights in spatial frequency, and it is means to smooth, moderate change and fast change, and it is a convolution with multiplication. So here there are so many images are there, A, B, C, D. Okay, so it is the original image. After the transformation, the original image like this. It is the original input image. The transformation output. It is the original input image. It is a transformer output image. Okay. So the alternative representation and sensing. Obtain transformed data as measured in radiology images, medical and astrologies in inverse transformation to recover image. So what is the inverse transformation means? We are recovering the original image. Efficient storage and transmission. So energy, compression, pick a few representatives and just store, set the contribution from each basis. Okay. So these are the transformation process. So the alternative representation of sensing. So I transformed one image. Okay. What are the alternate solutions for that one? So we are obtaining the transfer data as measured in radiology images, and we are inversing the transform to recover image. So a transformed image is there. Transformed image. Okay, we are applying the inverse. Then it is a inverse transform, that is called the recover image. And the efficient storage and transmission. So how? Energy, compaction and representation and contribution of each basis. So it is the original image, it is the incomplete image. Okay, so this incomplete image I have to convert because it is my input and it is my output. So how means image transformation technique. So what are the stages are there in the image transform? So first one, orthogonal sinusoidal basic function, non-sinusoidal basis function depending on statistical input of signal, directional transformation. So orthogonal sinusoidal basis function, non-sinusoidal orthogonal basis function, basic function of the depending on the statistics of input signal, directional transformation. So in this, how many types are there? In the orthogonal sinusoidal, Fourier transform, discrete cosine, discrete sine. And in the non-sinusoidal, Hare transform, Walsh transform, Hadamard, and a slant transform. And basis function depending on the statistical of the input. That is a KL transform, singular Weyl decomposition. So directional transformation through Hawk transform, random, reticular, and contrast transform. These are the techniques. But the main important is a Fourier transform and discrete Fourier transform or inverse Fourier transform. Okay. So image enhancement to improving the interoperability and the perception of the information in images for human viewers, and it is providing better input for automated processing. So what are the image enhancement means? Spatial domain and frequency domain. So what are the spatial? It operates directly on pixels. Frequency means it operates on the Fourier transform. Okay. Spatial means operating on directly. It is operating on Fourier. That is a frequency domain. So if the image has a image need frequency, we are going for the frequency domain transformation. Suppose I need spatial domain, that is the operating as a pixels directly. Okay, that image with pixels, that is the spatial domain. Okay, it is one example. Suppose I am taking one image with output gray levels, input gray levels, it is called comma R. Input gray levels are the R, output gray levels are the S. Input R, output S. So it is the inverse log in this like this. It is the identity and it is a logarithmic, nth root, nth power, and a negative. Okay. So when I am applying the frequency, I want to find out the frequency of the image. Then it is a Fourier spectrum. Okay. We have to find out the frequency of the image. Okay. It is a logarithmic transformation of the Fourier transform. Okay. We are converting to the original image. And it is another example of that one. It is a R equal to input and S equal to output. So inputs and outputs are in the form of gray levels. So the power law transformation, gamma correlation applications. The aerial view of this image. So in this image, there is a high brightness. So we are converting to the normal brightness. So it is some input. It is the output function. So this input function is a contrast low. So it is converting to the normal contrast. That means here here the contrast is very high. Here contrast is very low. We are converting to the very low contrast. So the piecewise functions can be arbitrarily complex. What is a piecewise linear transformation? So we have discussed what is a piecewise linear transformation function. So in this, what is the disadvantage of this function means it requires significant user input. That is a disadvantage of this method. But what are the examples of piecewise linear transformation function? That one examples of this function means contrast stretching, intensity level slicing, bit plane slicing. So what is a contrast stretching? Next, intensity level slicing and bit plane slicing. So if we are discussing these three things, then we'll get piecewise linear transformation methods. So here the image is the input gray levels and it is the outputs. So these are the levels 0, L by 4, L by 2, 3L by 4 and L minus 1. L by 4, L by 2, 3L minus 1, L minus 1. Okay. So it is the before contrast enhancement. Okay. I am considering as an input without enhancement. But here output after enhancement. After enhancement. So what is the difference? Here the contrast is very high. Contrast is very high. Here I am getting the normal contrast. Getting the normal contrast. So here it is the input and output function. Okay. Here the contrast adjustments are there from the input to output. So it is the bit plane slicing. It is the 8-bit bit plane 0. So these are the slicings of that one. So the input intensity and output intensity. Input intensity is X and output intensity is Y. So it is the input function, and what is the output intensity means we are identifying the color codings or intensity values of that one. So in the digital image fundamentals, elements of visual perceptions are there, image sensing and acquisitions are there, sampling and quantization is there, relationship between pixels, and spatial and gray level, linear and non-linear. Then only we will go for the gray level transformation. So all those things are belongs to image fundamentals. So in the basic gray level transformation, suppose how we are finding out the gray levels, how we are changing the gray levels, what is the need of gray levels to changing that one transform to another. So here all those things under image enhancement only. Suppose I am taking 3 by 3. These intensity values are 78, 50, 41, 0, 255, 28, 156, 18 and 0. So these are the intensity values. So I am applying also called gray levels. So when we are this gray level transformations means if I am changing these intensity values are change. So if I am changing these intensity values or gray levels, that is image gray level transformation. That is a basic gray level transformations. So in this we have to provide what is the need to change like this means to provide better enhancement and detailed image with non-enhanced image. And it is the image enhancement or what are the applications means we are using in the medical images and image capturing in remote sensing and in the image from satellites, etc. So from this all those things, those are the non-image enhancement techniques are there. We are converting to the image gray level transformation technique. So we are converting to the image enhancement. So the inputs of the medical images and the capturing image and the satellite images are non-enhanced images. For identification, these non-enhancement techniques are converted into the enhanced techniques. Okay. So what is the formula? Means is equal to capital T of R, and here R is the pixel input and S is the pixel output. Capital T is a transformation function, and the value of R, each value is S. The image enhancement can be done through the gray level transformation, which are discussing. So how gray level transformations are changing or transforming? There are three techniques are there: linear, logarithmic, power law. So these three techniques are the three different applications in the real-time applications we are using. And linear transformation, the first is a linear transformation. So in this linear transformation, it is a straight line, means it output and inputs are balanced. So in this input image, it is directly mapped to each other, and the same input image and output image is called the identity transformation. Okay, it is called identity. Identity transformation. So identity means x and y values are same. It is a common point for x and y values. And it is a negative transformation. So the second linear transformation is a negative transformation, which is inverted to the or identity the transformation. So exactly opposite. Why? Because here what are the whitish are there? Here I am converting to the black. So this white here converted to the black. Here the black is there. Here the black is converting to the white. So that is called the invert of the identity transformation. So input image we are inverting the means inversely proportional. Inversely we are taking. So white means converting to the black. Black is converting to the white. So we are invert of identity of the transformation. So in this negative transformation, the value of the input image is subtracted. That is the L-1, the mapped onto the output image. Okay. So input and output, that is the negative. So in here original image we are inverting. So what is the formula? Means S equal to L-1 minus R. So it is the output. So S equal to L-1 minus R. It is the equation. So here L-1 means 255 minus L equal to 256 minus 1 is equal to 255. So what is L-1 value is equal to 255 minus R. What is R value? Means the intensity values 0, 255, 127 like this. So the logarithmic transformation is the two types. That is a log transformation, inverse log transformation. So what is the formula for log transformation? S equal to C into log of R plus 1. During the log transformation, the dark pixels in an image expanded or comparing to the higher pixel values. The higher pixel values are kind of compressed in log transformation. This result is following by the image enhancement. So S equal to C into log of R plus 1. This is the original image with the logarithmic image. Okay. What is the original image? 8-bit. Logarithmic means C equal to 1. S equal to C into log of R plus 1. So here C equal to I am taking is a C equal to 1. Log of R plus 1 means what are the values are there? Those are the R. Here I am taking 0 means 0 plus 1 means 1. Log 1 equal to 0. So 255 means I am taking 255 plus 1, 256. Log of 256, 2.4. So log of here 50 plus 1, 51. What is the value? Means 1.7. So here the values of logarithmic values. After getting the logarithmic values, the output image is like this. It is the input digital image. It is the output logarithmic image. So the value of C in the log transform adjust to the kind of enhancement. So here C we are adjusting the image. Next one is a power law transformation. There are further two transformations in power law transformation that includes nth power and nth root transformation. These transformations can be given as expressed S equal to CR into gamma. So gamma is a constant value. It is a transformation value. It is a gamma transformation. So what is a transformation? What is the need of transformation? For a transformation is going for the better image processing. in the account of long range correlations, and it is a spatial frequency information, and it is a smooth moderate change and a fast changing, and it is for convolution and multiplication. Okay, so the representation and sensing of the alternate image is there to obtain the transformed data as measured in radiology image. So the inverse transformation is the recovery of the image. So what is previously we discussed what is a transform, but here inverse transform. Inverse transform is for recovering of the image. So the efficient storage and transmission, energy compactant, a few representatives, and the contribution from the image basis. So it is a, suppose I am taking it is the input image, that is the incomplete. So we have to imagine what is the output. We have to imagine. So in the transformation technique, I am applying the output. When I am going for the inverse, so it is the input. The inverse transform means it is a inversely means I am getting like this. So what are the stages are there in the image transform? Orthogonal sinusoidal basic function, it is the first one, and the second one non-sinusoidal orthogonal, third one basis function depending on statistics, and the fourth one directional transformation. So orthogonal sinusoidal basis function is a Fourier transform, and it is a discrete cosine transform, discrete sine transform. Non-sinusoidal means Hall transform, Walsh transform, Hadamard, and slant. And the third one is a basis function depending on the statistical input signal. That is a KL transform, singular value decomposition, and a directional transformation is a fourth type. These are the four subtypes of it. So in the image enhancement, we are improving the interoperability or perception of the information in an image for human viewers. It is providing better input for the automated image processing techniques. So in this, there are two types of methods are there: spatial domain method and frequency domain method. So spatial domain method is for operating the directly on pixels and operating on the Fourier transform of an image. So it is the image with Fourier spectrum, means frequency spectrum or frequency transformation of the image. The second image, it is the first image, and it is a second image. It is a logarithmic transformation of the Fourier spectrum, and it is one example. So here aerial image is there, one example, but here what is happening in the aerial view of this one, but here what is happening means we are contrast, we are adjusting the contrast, we are adjusting the brightness of the image from the aerial image. So for this one also we are using image transformation, that is a power law transformation or gamma transformation. So the piecewise functions can be arbitrarily complex. So what are the piecewise arbitrary complex functions? Contrast stretching, intensity level slicing, bit plane slicing. So it is before contrast of enhancement, means the input image without enhancement. It is the output image with after the enhancement technique. So here the input and outputs are the intensities with after the transformation. It is a before enhancement and after enhancement. These are the some examples of bit plane slicing. So there are different images are there, but what are the images are there means we are adjusting the brightness of the images. That is a bit plane 0, bit plane 7, it is a 1 bit 8 bit, and the least significance of the bits. And piecewise linear transformation function, input intensity, output intensity, okay, the balanced values, okay, and these are the digital image fundamentals, the elements of visual perception, image sensing and acquisition, sampling and quantization, relationship between pixels, spatial and gray level resolution, linear and non-linear operations. These are the digital image fundamentals. So after getting the knowledge of this image fundamentals, we have discussed gray level transformations. In this gray level transformation, what is transform? What is inverse transform? And these are all where we are using. So what is the need of transformation means better image and adjusting the contrast of the image. That is the reason we are going for the image enhancement or gray level transformation. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.